Hey guys, my name is Sam, and welcome to my Lab 3 for Physics 2, which is about dipole magnets. So the purpose of this experiment is to observe how important it is to have an object close or far away from a magnetic field and how that affects the magnetic field influence on the object. And to calculate that, we're going to use the Biot-Savart law to find the magnetic moments of the bar magnet. And to visually observe the relationship between a point and how the magnetic field affects it at different distances. And so a little bit of a brief overview of my results. For my mu, I had 1.4, and then my B net observed was 2.93 e to the negative fifth, then my B net theoretical was 1.9 e to the negative fifth. So before I get into the experiment, I do want to go over a little bit about how this experiment was set up. So first thing that I needed to do was find where the magnet was the strongest. Basically, I had a ruler with a magnet at the end, and I moved my phone perpendicularly and parallelly to the ruler until I found the maxima on the x and y plane. And then after finding where those two overlapped, I determined that was where the magnet was strongest. And I also, for the assumptions, I assumed that the magnet would behave as a magnetic dipole and that all other magnetic fields, excluding the Earth's magnetic field, which we'll talk about later, are negligible and should not be accounted for in this lab. Alrighty, and I do kind of want to show this visually. So as I said, we had the roller and then the magnet on one side, and then I used my phone and moved up and down, side to side, until I found where the manometer showed the red X. And then also just in the bottom photo, I did want to show that I did rotate my phone to adjust for Earth's magnetic field because I didn't want any of my results to have, I guess, a sort of bias towards Earth's magnetic field. Now just to show some of my calculations that I got from the Excel sheet. So my linearization line showed that y was equal to negative 3x minus 14.8. So it was a downward slope. Then my n, as a result, was negative 3. Then also as a result, the natural log of k was negative 14.8, which meant that k, after applying like e to the for both sides, was 3.8 e to the negative 7th. And then next, I calculated mu by deriving not deriving, but I guess readjusting all the variables for the Benoit-Savart law. And since r is equal to 1, I got that mu was equal to 1.9. Alright, now we can get into some of the code, which is kind of long. But in the beginning, I just have my constants, and then also my magnet model, and also what I observed mu to be based on my calculations. Then moving forward, I used the Biot-Savart law, and I plugged in every part of the equation in order to figure out what the rest of these variables would be in the code. And I set up the magnetic field based on how far each arrow will be from the origin, aka the magnet. So I scaled up the arrows so we could see them. I calculated the observed distance and then also the observed locations based on that distance. Alrighty, and then I had to put the arrows into the final result image. So there's 6 arrows in total, 5 which are on the plane of like straight up and straight across from the magnet, then also 1 which was kind of going off towards the positive infinity direction on the x and y axis. And like I said, that's the one diagonal arrow that's going towards positive infinity, which I got from the script that Dr. Greco gave us. And lastly, what you've been waiting for is the results of the experiment. So like I said earlier about what mu and b net were, the observed and theoretical b net were at an error of 65%. As you can see, they are very different numbers. Because they're not equal, that does mean that there's errors in our calculations. So what I felt were the main errors were, one, you can't fully account for negative mg because it is so large from the Earth. There also, I low-key kind of bumped my phone a little bit, but just in general, I kind of have shaky hands, which I think may have unintentionally moved the phone. And also interference from objects in the surroundings, which I obviously cannot account for every single one. But seeing as I did this in family, there were probably a lot of electrical forces that were affecting it. And I just added this little roll piece at the bottom because we beat Duke this last Saturday. Anywho, let's talk about the what ifs for what if we had not adjusted the phone to compensate for the Earth's magnetic field. So the results for our experiment would have been less accurate because the y value of every single vector would have been decreased because the Earth has a magnetic pole of negative 9.8 on the y-axis. The measurements would have had a bias towards that, and because of that, my lab results would be very different, which would not have been good for the accuracy of this report. Thank you for watching.